All right, so this is group 17. This is our second lab where we're analyzing and visualizing the Spotify data with Python. My name is Justin DeCoke.
And my name is Ranjith Kumar.
My name is Sachin Patel.
A quick overview of the Spotify data set. So there's 1,000 unique rows, and each row is down to kind of the song level. So each song is a song on the Spotify's top hits playlist. And the vast majority of the songs included were released between the years 2009 and 2021. To be exact, there were 999 songs released between those years, and one song released in 1975. And to set up the Jupyter notebook and import all of our libraries and import the data and everything, we used both Pandas and Matplotlib. We used the read CSV function from Pandas to read in the CSV that was provided in the assignments. And then we also used the Pandas toDateTime method to convert the added column to a datetime object without having to explicitly import the datetime library. So to answer the first question, which was to find the number of entries added in the month of March. So for this, we used the pandas dt.month function to which accesses the datetime object, and filters it down to only the month of March, or the third month. There were three submissions in the month of March. All right, and for question 2, finding the maximum duration for each year, or basically the longest song of each year. So we passed year released into the group by function, and then we aggregated the duration column with .max, and then that got us this right here, which shows us the year released and then the maximum duration for that year. To get any other columns to show up, we had to take an alternative approach and use actually a combination of the .loc function and the IDXmax function. So the IDXmax function returns the index of the maximum duration, and then that is passed to the .loc function as the index, and then we choose all of the columns that we want to see from that specific index. So it's quite similar to a SQL subquery in the where clause of select statement. So that gets us the artist and title of each of the longest songs. So we can see that one song from 1975 is Bohemian Rhapsody, and then there's nothing until 2009. All right, so questions 3 and 4, finding the number of songs released by artists. So question 3 is the total songs released by them over all years. These are not just songs released by them, but songs released by them in the playlist. So Taylor Swift released 21 songs between 2009 and 2021 that made it into the playlist. Drake 18, so on and so forth. To answer question 4, we just took a subset of the data as filtered down to only 2010, and that shows us that Kesha had 6 songs released in 2010 make it to the playlist. Bruno Mars had 5, and so on and so forth. Question 5, the number of songs released for each top genre in each year released. So we grouped by genre and year released this time, and then passed title to the .count function to count the number of songs released with this group by. So that shows us that each of these first years in the .head dance pop with the largest amount. Okay, so now we get into our data visualization. This is just a quick slide to give an overview of the function methodology. So each function has a ax parameter and a title parameter that's passed to it, which you can see here. So that is done so we can call a fig or create a figure with as many axes as we want, and then as many different functions can fill those axes on one subplot. And then it works as just a single figure as well, by still doing a subplot, but only doing a 1-by-1 grid, and then calling it once. So that will make sense as we get into the next few slides here. So this is our first plot visualizing the number of songs added to the playlist by month and year. So we can see that the vast majority of these songs were added in June of 2020. And we use the pandas datetime to-period method by month, and that got us these groups of month and years. You pass an ax and a title to it, which is done down here. And you can see the title translates right there. You do ax.bar and all of your different manipulations to the axis. This is our code to plot the number of songs released by top genre for all years. So there are a few variables here: min year, max count. These are passed into set x ticks and set y ticks, so that we get a year ticked on the x-axis for every single year in the data set. The max count uses floor division here, basically to get the highest data point that we'll be plotting, and then it finds the next multiple of 5 above that, just for cleaner plotting, which we can see here. It adds a little bit of space at the top. This shows that there are 132 top genres in this data set, and it also visualizes the fact that there's one single entry in 1975, and all of the rest are over here from 2009 to 2021. So to fix that, we made a subset of the data that excludes that year, so it only gets ones higher than that. And then also in this function, we have this num genres optional parameter. It's optional an optional parameter because the default is none. And that is used if that is passed, that is used to get only the it uses the in largest function here from Pandas, which only gets essentially the top in number of genres. So if we leave it closed, it gets us all of them still, but only with the years 2009 to 2021. So this shows that. So this top one it was this call right here, which doesn't specify anything. And then the bottom one here is this one, which you can see X1 and X2, and this one specifies num genres 5. So we only get the top 5 genres here. So finally, we noticed that there's 131, 132 individual top genres, and all there's quite a few hip hop, quite a few dance, all different types of pop, etc. Makes it kind of difficult to plot, and a lot of these genres wouldn't necessarily mean anything to somebody. So we binned them together into these 10 more common genres: pop, hip hop, rap, rock, etc. With a dictionary, and then using the pandas.apply function here, we wrote this function, normalize genres, and passed it to the .apply function. So basically, it takes each individual row of the data frame, that's what this is, and creates a new genre column. And it applies this normalized genres function, which is a for loop, which looks for any of these substrings in the top genre value. And if it matches one of these, it's assigned one of the binned genres. With this dictionary, it picks up all of the top genres and puts them into these 10 genres here. So this shows the number of the top genres that went into each of these binned genres. So this shows a similar distribution of the number of songs released by those genres. So finally, plotting those new genres to the same sort of line plot, we made this similar function, and we plotted it, and then we also plotted the 3 together. So this shows the normalized genres, or the binned genres, narrowed it down to. And what we found very interesting is the hip hop and rap genre had, when they're binned together, have quite a spike here, starting in 2016-ish and going through 2018. And then together, you can see that spike with the hip hop rap here, but we don't really see any individual genre get quite as close to dance pop here as we see hip hop and rap binned together get as close to pop here. So we thought that was interesting, and we also the top one here shows the how much better we can visualize the data with it excluding that single odd entry of that year. So lastly, we have VS Code open, and we'll do a run all on our notebook, and we can scroll through and see that everything works as it should. Here's where our plotting starts. Here's where we did our binning. And then here is the final graph. And then here is the metrics of what's in those new genres. So that was our project, and thank you.